Hello, my brilliant students. If you are getting ready to absolutely smash your WAEC, NECO, or JAMB Physics exam, then you are in the perfect place. Today, we're diving into a topic that is a sure banker for marks, something that's guaranteed to show up: light and optics. Yes, you heard me right, light and optics. Now, I don't want you to see this as just another difficult topic. No way. This is your secret weapon. It's a high-scoring area that the examiners love, and once you get it, you're grabbing some serious marks. Trust me, by the end of this session, any question they bring, you'll be ready to tackle it head-on. So let's get into it. So here's our game plan. First, we'll look at the exam roadmap, what WAEC and JAMB actually expect you to know. Then we'll build our foundation with reflection and refraction. After that, the fun part, we'll solve real past questions together. And to finish, we'll do a quick recap with some killer exam tips, simple and straight to the point. Alright, first section, why are we spending time on this? Well, let me tell you. This topic alone can make up about 10 to 15% of your entire physics exam. Ha! That's a huge deal. And don't worry, everything we're about to cover is pulled straight from the official syllabus, so you can relax knowing this is exactly what you need to succeed. So pay very close attention. Now, these are the main things the examiners want to see that you know. We're going to talk about how light travels, how it bounces off mirrors, both the flat ones and the curved ones you see on cars. We'll even cover cool stuff like total internal reflection, which is the magic behind fiber optic cables for the internet. And finally, we'll get into lenses, like the ones in glasses or cameras. Don't let the list scare you. We're going to break it all down, step by step. Okay, section 2, let's get down to the basics with light and reflection. You know, you can't build a strong house without a solid foundation, right? It's the same thing in physics. We need to get these fundamental ideas locked down before we can tackle the bigger stuff. So let's start from the very beginning. First off, where does light even come from? It's really simple. We have two types of objects, luminous and non-luminous. Luminous objects like the sun or the light bulb in your room, they produce their own light. But most things you see, like the moon, this book, even your own face, we are all non-luminous. We don't produce light. The only reason you can see me is because light from a bulb is bouncing off me and going into your eyes. Simple, right? Now, don't let this big grammar confuse you. Rectilinear propagation. All it means in simple English is that light travels in a straight line. That's all. And this simple fact explains why you get shadows. When you block the straight path of light, a shadow is formed, with a very dark part, the umbra, and a lighter part, the penumbra. It's also the reason we have amazing things like solar and lunar eclipses. So you see, a simple rule explains so much. So, what happens when light hits something shiny, like a mirror? It bounces off. We call that reflection. But it doesn't just bounce off anyhow. It follows two very strict laws. The first law just says everything, the incoming light, the bouncing light, and the normal line, they all stay on the same flat surface. The second law is the important one for our calculations. The angle at which light comes in is the exact same angle at which it leaves. And when we start dealing with curved mirrors, that mirror formula you see right there, that is your best friend for solving problems. Let's use it now. Okay, let's solve a typical exam question. We have our formula, 1 over f equals 1 over u plus 1 over v. The question gives us f is 20 and u is 30, so we slot them in. We get 1 over 20 equals 1 over 30 plus 1 over v. Now we just need to do some simple math to find v. We rearrange it to get 1 over v equals 1 over 20 minus 1 over 30. Find the LCM, which is 60, and you get 1 over v is equal to 1 over 60. That means v is 60 centimeters. Easy. But what does the answer mean? Since v is a positive number, the image is real. For magnification, it's minus v over u, which is minus 60 over 30, which gives us minus 1. The minus sign tells you the image is inverted or upside down, and the 1 tells you the image is the exact same size as the object. You see how it all connects? Great job. So we've handled reflection, which is how light bounces. Now let's move on. What happens when light doesn't bounce, but actually passes through something, like from air into a block of glass, or from air into water? This is where light starts to bend, and this is where things get really, really cool. This bending of light is called refraction. So why does it bend? Well, it's because light changes speed. Think about it like this. Imagine you are running on a smooth, tarred road, and you suddenly run into a sandy area. You will definitely slow down and probably change your direction a bit, right? That is exactly what happens to light. And the formula that helps us calculate this bend is called Snell's law. It's a very important formula you must know for your exams.
Okay, everybody, listen up because WAEC and JAMB love this one. It's called total internal reflection, or TIR. It's a special situation where light is moving from something dense like glass to something less dense like air. If it hits the surface at a very sharp angle, an angle bigger than the critical angle, it doesn't escape. It gets trapped and is completely reflected back inside. This isn't just theory, oh no. This is the technology that powers the internet cables bringing you this lesson right now. And it's also why diamonds sparkle so beautifully. Now, let's talk about lenses, like the ones in eyeglasses. They work using the same bending of light, refraction. And I have some great news for you. The formula for lenses is exactly the same as the one we used for mirrors. 1 over F equals 1 over U plus 1 over V. We also have a new idea, the power of a lens. But please, I'm begging you, take note of this exam trick. To calculate the power, the focal length F must be in meters. They will give it to you in centimeters to trick you. Don't fall for it. Let's quickly solve one more. Same formula. We plug in F is 10 and U is 20. We rearrange the equation to find V, just like before. 1 over V equals 1 over 10 minus 1 over 20. Do the fraction math and you get 1 over V equals 1 over 20. So V is 20 centimeters. Again, since it's positive, the image is real. For magnification, it's minus V over U, which is minus 20 over 20. That gives us minus 1. The minus tells us it's inverted, and the 1 tells us it's the exact same size as the object. You see how it all connects? Okay, enough with the theory and examples. It is time for the real deal. We are now going to solve actual original past questions from WAEC, from JAMB, and from NECO. This is how you convert all this knowledge into real marks in the exam hall. Let's go. Look at this. This is straight from the WAEC 2020 theory paper. Take a second to read it. They asked for 3 things: define critical angle, state the conditions for total internal reflection, and list 3 applications. Wait a minute. Doesn't that sound very familiar? Of course, we literally just covered this a few slides ago. This is to show you that what we are doing here is exactly what you will see in your exam, and this is how you answer it perfectly to get all your marks. For part A, you give that exact definition. For B, you list the 2 conditions clearly. And for C, you give them 3 solid examples. And here's an expert tip. Some students confuse critical angle with something called Brewster's angle. They are not the same thing at all. Make sure you know the difference so you don't lose cheap marks. Alright, let's look at a JAMB question. This is a typical calculation problem they like to set, this time about fixing eyesight. They give you the numbers and they want you to find the power of the lens. This is a very practical question. Okay, let's solve this one together. The object is the book at the normal distance, so U is 25 centimeters. The eye can only see clearly from 50 centimeters, so the lens has to create an image at 50 centimeters. Now here's the crucial trick. Because the image is on the same side as the object, it's a virtual image, which means V must be negative. So V is minus 50 centimeters. If you forget that minus sign, you'll get the question wrong. So we put these values into the formula. We solve and get F equals 50 centimeters. But they want power, so we convert to meters. F equals 0.5 meters. Power is 1 over F, which is 1 over 0.5, giving us plus 2 diopters. Answer is A. That minus sign for V was everything. And now for a NECO question. This one looks very simple, but it is a classic trick question. It's about a simple plane mirror, but you have to be careful with the distances. Read it carefully. Here's how to solve this without getting tricked. First, find the distance from the object, which is the parade, to the mirror. the parade is 6 meters behind the man, and the man is 0.25 meters from the mirror. So the total distance from parade to mirror is 6 plus 0.25, which is 6.25 meters. Now, for a plane mirror, the rule is simple. Object distance equals image distance. So the image is 6.25 meters behind the mirror. But the question asks for the distance from the man to the image. So we add the man to mirror distance, 0.25, to the mirror to image distance, 6.25, and that gives us a total of 6.50 meters. And there you have it. Wow, that was fantastic work. We have covered the theory and we've solved real exam questions. Now let's just package all of this knowledge nicely. Think of this last section as your quick cheat sheet for exam day success. Okay, this slide is pure gold. Pause the video, take a screenshot, write these down. This is your formula summary. The mirror and lens formula, magnification, Snell's law, critical angle, and lens power. You need to know these formulas by heart. They are your tools for solving any calculation question. And finally, my personal top tips for you. 1. Always draw a small diagram. It helps you see the problem clearly. 2. Please master the sign conventions. That positive and negative thing is where most students make mistakes. 3. For theory questions, define your terms first. 4. It helps to memorize a few things, like the critical angle of glass is about 42 degrees. And 5. Check your units, especially that centimeters to meters conversion for power. Don't let them trick you. You have done an amazing job today. You've tackled a very important, high-scoring topic, and you should be proud. You can do this. Now, a final quiz for you to think about. We saw that for long-sightedness, we used a convex lens with a positive power. So for short-sightedness or myopia, what kind of lens would you use, and would its power be positive or negative? Ponder on that. If you found this lesson helpful, please like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also visit www.examkp.com for thousands of practice questions and answers. Let's smash these exams together.